Dear students, welcome to my classroom. In previous class, we discussed about conversion of solids from one shape to another shape. And also we solved two problems in exercise 10.4. And in this class, we are going to solve remaining problems in this exercise. Okay, so let's take third problem. A 20-meter deep well of diameter 7 meter is dug and the earth got by digging is evenly spread out to form a rectangular platform of base 22 meters by 14 meters. Find the height of the platform. So this is the question. Students, I think all of you know that what is the shape of well. In this picture we are looking a well which is in the shape of a cylinder, isn't it? The well is in the shape of cylinder, and in this question a well of diameter 7 meter is dug and the earth got by digging is evenly spread out to form a rectangular platform of base 22 meter into 14 meter, like this. So here the shape of well is cylinder and the earth got by digging this well is evenly spread out in the form of a rectangle whose measurements are 22 meters by 14 meters. Okay, so we have to find the height of this rectangle platform. That is, by how much height this earth will be grow. Okay, so here the measurements of cylinder and rectangular drawn out. So we have to find the height of this platform. So let h be the height of the platform. So given the diameter of well is 7 meters, so that the radius of well is r is equal to half of the diameter, that is 3.5 meters. And now depth of well, that is the height of this cylindrical shape, is capital H is 20 meter. Now for the rectangular platform formed by earth dug out from well, that is for this shape, length is given 22 meter, which is denoted by L. Breadth is 14 meter, given by B, and let the height of this platform be H. Now the volume of earth dug out is equal to the volume of this cuboid. Okay, so the volume of earth dug out from well is equal to volume of platform which is in the shape of cuboid. So the volume of earth is in the shape of cylinder. So the volume of cylinder, we know that pi r square h, and volume of platform is LBH, L into B into H. Now substitute the values of pi, R, capital H, L and B. So from this we get the value of small h, that is the height of platform. Okay, so pi is 22 by 7, R is 7 by 2, and H is 20, L is 22, B is 14, and the height of platform is H. So from this we can write H is equal to 22 into 7 into 7 into 20 by 7 into 2 into 2 into, by transforming these two terms to this side, we get by 22 into 14. So by simplifying this one, we get H is equal to 2.5. That is the height of the platform is 2.5 meters. Okay. So take the next one. A well of diameter 14 meter is dug 15 meter deep. The earth taken out of it has been spread evenly to form circular embankment of width 7 meter. Find the height of the embankment. So this is also like previous problem. So here it is the well whose diameter is 14 and its depth, that is height of the depth of the well is 15 meter, and the earth dug out from this well is evenly spread around this well as embankment, circular embankment, like this. Okay, so the measurements of this embankment are, so its width is as the radius of this cylinder shape is 7. The radius of this embankment is also 7 meters. Here the radius, here the embankment is in the shape of a cylinder whose outer radius or inner radius is 7 meters, and as the width of this embankment is 7 meters, which is given in problem. So the outer radius of this embankment is 14. 7 plus 7, 14. So that is its inner radius is 7 meters and outer radius is 14 meters. And the height of the cylinder is 15 meters. A diameter of cylinder is 14 meters. Okay. So we have to find the height of this embankment. Okay. So given that the height of well is 15 meters and diameter D is 14 meters and width of embankment is taken as W is equal to 7 meters. This one. Okay. Now the radius of well is R equal to half of the 14, half of the diameter, that is 7 meter. So for the embankment, now for the measurements for the embankment are inner radius is R1, inner radius denoted by R1 is equal to 7 meters, and outer radius is R2 is equal to R1 plus W, that is inner radius plus width of embankment, that is 7 plus 7, which is equal to 14 meter. So this one is denoted by R2. And now let the embankment, height of embankment be H, that is the height of this cylindrical shape is H, like this. Now volume of well is equal to volume of embankment, because so the here the earth dug out from well is evenly spread out around this well. So the volume of well is volume of embankment, and we know that volume of well is the volume of cylinder whose measurements are radius is 7 meters and height is 15 meters. So volume of well is pi r square h, and volume of embankment, that is volume of earth dug out, is volume of embankment is equal to volume of outer cylinder minus volume of inner cylinder, because in between cylinder in the inner circle there is no matter, so that we have to take the volume of this embankment is equal to volume of outer cylinder minus volume of inner cylinder, that is pi r1 square h minus pi r2 square h. So here we have to take r2 square. Okay, sorry, pi r square h is equal to pi r2 square h minus pi r1 square h. Okay, now substitute the values of small r, capital H, r1, r2 in this equation. So before that take h common, pi h common. So from that we get pi r square h equal to pi h into r2 square minus r1 square. So we can cancel pi on both sides and we remain with r square h is equal to h into r2 square minus r1 square. From this we can write h is equal to r square h by r2 square minus r1 square. And now by substituting values, h is equal to r is 7 H is equal to 15, R2 is 14, R1 is 7. So we get H is equal to 735 by 147, which is equal to 5. Okay. So the height of the embankment is 5 meters. Okay. So let us take fifth one. A container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. The ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter, having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. Okay, students. So here we have a container whose measurements are diameter 12 centimeter and height 15 centimeter, and it is full of ice cream. Oh, okay. Here the pink shape is ice cream. Pink color is ice cream. And this ice cream is to be filled into cones whose height is 12 centimeter and diameter is 6 centimeters. So these are the cones, and the ice cream to be filled in these cones like this. So here it is asking that how many cones are required to fill the ice cream in this cylinder. Okay, so take one cone and cylinder, and for this cone and cylinder, the measurements of cone are diameter 12 centimeter, height is 20 centimeter. Sorry, here the height is 15 centimeter, and the height of cone is 12 centimeter, and its diameter is 6 centimeter. So now we have to find that how many cones are required to fill the ice cream in given cylinder. Okay, so take first, here we have three shapes. First one is cylinder, second one is cone, and third one is hemispherical. Okay, so for cylinder the measurements are diameter is d is equal to 12 centimeter, radius is r is equal to half of the diameter, that is 6 centimeter. Here I am taking the radius as capital R, and the height is given capital H is equal to 15 centimeter. Now the volume is pi capital R square H. So by substituting values of R and H, R equal to 6 and H is equal to 15, we get 540 pi cubic centimeter. Okay, so the volume of ice cream in cylinder is 540 pi cubic centimeter. And now let us take cone, and for the cone diameter is 6 centimeter, so that its radius is 3 centimeter, and its height is given 12 centimeter. So the volume of cone is 1 by 3 pi r square H. So by substituting r is equal to 3 and H is equal to 12, we get volume of this cone is 36 pi cubic centimeter. And now take hemisphere, which is on the top of cone, and for this hemisphere the radius is equal to the radius of cone. So the radius of cone is r equal to 3 centimeter. So its volume is 2 by 3 pi r cube, and by substituting r equal to 3 we get 18 pi. So now the volume of this ice cream cone is equal to 36 pi plus 18 pi, that is volume of cone plus volume of hemisphere. So 36 pi plus 18 pi, which is equal to 54 pi. So now let the number of ice cream cones required be n. As all the ice cream filled in ice cones, then volume of ice cream in cylinder is equal to n into volume of ice cream cones. That is 540 into pi is equal to n into 54 pi. From this we can write n is equal to 540 pi by 54 pi, so that which is equal to 10. So the number of such cones required is 10. The number of cones that can be filled with ice cream is 10. So let us take sixth one. How many silver coins 1.75 centimeter in diameter and thickness 2 millimeter need to be melted to form a cuboid of dimensions 5.5 centimeter by 10 centimeter by 3.5 centimeter? Okay. So here I have some silver coins. So I have to find the number of coins, and these silver coins are melted to form a cuboid. Okay. And we can see that the shape of these coins are cylinders. Okay. Shape of each coin is cylinder. So coins are here cylindrical, and these coins are melted to form a cuboid whose dimensions are 5.5, length 5.5, width 10, and breadth 3.5 centimeter. Here the dimensions of coins are diameter is 1.75 centimeter and thickness is 2 millimeter. Okay. So for cylindrical silver coin, measurements are diameter is 1.75 centimeter. So its radius is 1.75 by 2 centimeters. And its height is 2 millimeter. So as the radius is given centimeter, we have to convert it into centimeter. So 2 millimeters is equal to 2 by 10 centimeter. And its volume is pi r square h, that is 22 by 7 into r is 1.75 by 2 and h is 2 by 10. So keep this value same and take the cuboid. And the length of cuboid is capital L is 5.5 centimeter, breadth is capital B is 10 centimeter, and height is capital H is 3.5 centimeter. And now the volume of this cuboid is L into B into H, that is 5.5 into 10 into 3.5. So now the number of coins needed to, let the number of coins needed to form a cuboid be n. Then volume of cuboid is equal to n into volume of each silver coin, because by melting these n coins, the cuboid is formed. So the volume of cuboid is equal to sum of the volumes of these n silver coins, that is n into volume of each silver coin. So from this we can write volume of cuboid is this one and volume of silver coin is this one. So by substituting these values in this one and by rewriting it as n is equal to 5.5 into 10 into 3.5 into 7 into 2 into 10 by 22 into 1.75 into 1.75 into 2, we get 400. N is equal to 400. That is the number of silver coins needed to form cuboid is 400. Okay, students. Now take the seventh one. A vessel in the form of an inverted cone. Its height is 8 centimeter and the radius of its top is 5 centimeter. It is filled with water up to the rim. When lead shards, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shards dropped into the vessel. So here we have a conical vessel filled with water and its height is 8 centimeter, radius of the top is 5 centimeter, and it is filled with water up to the rim. And there are some lead shards which are in the form of spheres and whose radius is 0.5 centimeter. And these lead shards are dropped into the vessel. Then 1/4 of the water flows out like this. Okay. Now we have to find the number of lead shards dropped into the water, that is into the conical vessel. So here I am taking showing only 3, but we have to find the number of these lead shards. Okay, so take one lead shard and the cone, and the measurements of cone are radius is 5 centimeter, height is 8 centimeter, and the radius of the sphere is 0.5 centimeter. And for conical vessel, radius is r equal to 5 centimeter, height is h is equal to 8 centimeter, so that its volume is 1/3 pi r square h, and by substituting where r is equal to 5, h is equal to 8, we get 200 pi by 3 cubic centimeter. This is the volume of conical vessel. Now, for the sphere, that is for spherical lead shards, radius is given 0.5 centimeter. That is 5 by 10, which is equal to half centimeter. Okay. Now, the volume of this lead shards is 4/3 pi r cube, and can be written as 4/3 into pi into r is 1/2 into 1/2 into 1/2, which is equal to pi by 6. By simplifying this, we get pi by 6. That is the volume of each spherical lead shard is pi by 6. Now, for 1/4 water flows out from conical vessel, let the number of lead shards that to be dropped in vessel be n. Then the volume of water flows out is equal to n into volume of lead shards. But the volume of water flows out is 1/4 of the volume of cylinder. Okay, so that is 1/4 of the volume of cylindrical vessel is equal to n into volume of lead shard is volume of sphere. And by substituting volume of vessel and volume of sphere in this one, we get 1/4 into 200 pi by 3 is equal to n into pi by 6. And from this we get n equal to 50 into pi into 6 by 3 into pi, which is equal to 100. So that the number of lead shards that to be dropped into the vessel is 100. Okay. So now take the 8th one. A solid metallic sphere of diameter 28 centimeter is melted and recast into a number of smaller cones, each of diameter 4 2/3 cm, that's centimeter, and height 3 centimeter. Find the number of cones so formed. Here, the sphere melted and formed into cones. So we have to find the number of cones so formed. Here the measurements of sphere, metallic sphere is given, and the measurements of cone is also given. Okay, so this is the metallic sphere, and these are the cones which are made by melting this sphere. So I am taking a cone. The radius of sphere is 28 centimeter. Diameter of cone is 4 2/3 centimeter, and height is 3 centimeter. So for metallic sphere, diameter is d is equal to 28 centimeter. Radius is r equal to 14 centimeter, and volume is 4/3 pi r cube. And by substituting r equal to 14, we get 10,976 pi by 3 cubic centimeter. And now for the smaller cones that you have made from the sphere, diameter is given 4 2/3, that is 14/3 centimeter. So the radius is half of this 14/3, that is 7/3 centimeter. Let the height of this cone BH is equal to 3 centimeter. And now volume of these smaller cones is 1 by 3 pi r square h. That is 1 by 3 pi into 7 by 3 into 7 by 3 into 3, which is equal to 49 pi by 9. And now let the number of cones so formed is n. Now the volume of this sphere is equal to sum of the volumes of all cones so formed. That is, the volume of sphere is equal to number of n into volume of each cone. So by substituting volume of sphere 10,976 pi by 3 and volume of cone 49 pi by 9, so we get n is equal to 224 by into 3, that is 672. So the number of cones so formed by melting metallic sphere is 672. Okay, students, that's the end of this chapter, mensuration. So shall we meet in next class with a new chapter? Until then, see you. Bye.